Alright, hey kiddos. Alright, so here is the video for 12.5 during my absence on multiplying and dividing rational expressions. Now, we've already dealt with adding and subtracting, which was kind of tricky, but this is actually a little bit easier. It's just dealing with some of the skills that you've already looked at. So let's start with the first example. So here's our first rational expression. We have 3x squared over 2x, and we're going to multiply by 8x cubed over 15x. So the first thing that you can do, you actually have a million different options of how to attack a problem that looks like this, where we have a monomial over a monomial times a monomial over a monomial. You can either simplify either down first, so we can deal with these guys and see if we can do any simplification. You can simplify across, so doing some cross-canceling as a normal fraction would. Or you can just go ahead and multiply across and then do some reducing. So you really have a lot of options here. Personally, I think it's easier to simplify down, so I'm going to kind of do a combination. I'm going to go ahead and do a combination that I see that I have an x squared and an x, meaning I can cancel off one of these and cancel off this x. I can do the same for these x's. I've got 3 here and 1 here, so that would leave me with 2 up in my numerator. And then I can't really simplify 3 and 2 or 8 and 15, but I can actually simplify cross-cancel in mathematics. I mean in fractions. So I can cancel this off, this becomes a 1. I can cancel this off, this becomes a 4. And then I can do the same cross-canceling here. I can cross-cancel this 1, this becomes a 15. And I mean a 1, and this 15 divided by 3 is 5. And then I'm going to multiply across. What do I have left? I have 1 times 4x squared. So that means I have 4x squared left in my numerator, and then I have 1 times 5. And I'm left with just purely 4x squared over 5. I could have actually just gone ahead and multiplied totally across. If I had done that, I'm going to rewrite my problem real fast. If I had done that, we would arrive at the same answer. If I multiplied purely across, I'd wind up with 24x cubed, correct? 24x cubed, and then 2 times 15 is 30x squared. And then I could say, hey look, I've got 2x squareds here, so I can cancel one of those off, and then I can divide both of those by, what, 6? 6 is probably the largest thing that goes into them. So 30 divided by 6 is 5, and 24 divided by 6 is 4, and I wind up with 4x squared. Something happened weird here. Oh, I left my cubed here. That's what happened. I ended up with 5 here and 3 up here. This would be 3 left and a 5 left. There we go. Simple little error. So you end up with the exact same answer regardless of which way you attack this problem. Getting a little bit harder. Okay, so now instead of just monomials, let's have some binomials and trinomials and polynomials. Oh my! Lions and tigers and bears, oh my. Here we go. So I have 3x plus 6 over 3x squared plus 18x plus 27, and I'm going to multiply by x squared minus x minus 12, a huge polynomial, over x squared minus 4. First step I'm going to go ahead and write is factor. Go ahead and factor out everything that you can. So I'm going to start with this one. I can factor out of my numerator here, I can factor out a 3. So I'd be left with x plus 2. And then I'm going to go ahead, oh look, I can actually factor out a 3 out of this guy. I'm going to factor out a 3 out of here, and I'd be left with x squared plus 6x plus 9. I'm going to go ahead right now and factor this numerator over here, and that would be x times x gives me x squared. Negative 12 is going to be 4 and 3, a negative 4 and a positive 3, all over. And then this one is the difference of squares, which is x plus 2 times x minus 2. I can also go ahead and refactor this one. So in my third step, I'm going to move this up. In my third step, I have 3 times x plus 2 all over 3. I'm going to factor this guy out a little bit more. So that'd be x times x. 3 times 3 will also add up to 9. So it's positive 3 times x minus 4 over x plus 3 all over x plus 2 times x minus 1, x minus 2. Whew! And now, second step is I can cross-cancel. I can cross-cancel and then multiply across. and multiply. I'm going to shift this up a little bit and multiply across. So I'm going to go ahead, I can cross cancel this x plus 2 and this x plus 2. I've got 1x plus 3 here and 1x plus 3. And then I also have 3 divided by 3. 3 divided by 3 is 1, so I can cancel those off as well. And then I multiply across. All I have left in my numerator is 1 times all this junk, which is x minus 4 in my numerator. And then I have x plus 3 times x minus 2. You can leave this in factored form, as that will help us to look for excluded values later on. All right, last example that I have is a division problem example, very similar. So example number 3 looks like this. N squared minus 6n plus 9 all over 12n divided by n minus 3. And I'm going to put those in parentheses. So just if you remember with fractions, if you're dividing fractions, what you do is you take the second term, you're going to take the first term stays the same. The second term, you turn this into a multiplication problem and you flip, this is really over 1, right? We flip the second fraction. So instead of it being n minus 3, it's now 1 over n minus 3. Now I need to factor. I'm going to go ahead and factor my numerator. This is positive 9, so it's going to be 3 times 3, but a negative 6, so this is both negatives, over 12n, times 1 over n minus 3. I can now cross cancel because I have a multiplication problem, and I'm left with n minus 3 over 12n. And that is as far as I can go. Ladies and gentlemen, have a good weekend, and hopefully this lesson is pretty easy for you.